So
Hello
why
friends,
we need
welcome back to my YouTube
non-relational
channel
database
TechMeetNavneet.
and why
Here we
data
are
is
with
required to
part
be
3
stored in
non-relational data on
semi-structured
Azure
format.
on our Microsoft
So for that
certified
we
Azure
need to
Data
see how
Fundamentals course,
internet
that
has
is for
changed the way
DP900
we package the
certification.
data to send around, especially
Please
in
subscribe to
last
my channel, hit the
15
like
years
button,
or
share it
maybe
with your
last 20
friends,
years.
colleagues and to
So you
all
can see
who can get
Facebook
benefited of
started
my
around
videos.
2004,
Please help
Google,
me to
Twitter,
reach out to
Google around
maximum audience.
1998, Twitter around from like around
So in this
2006.
course,
Also we
we
have
have
YouTube,
already learned
Netflix.
about core
So
data
these
concepts.
companies which
Then we
provide their
learned about
service over
relational data
internet
on Azure.
and
In this
people,
video,
normal person,
we are
they
going to
take the
learn describe
subscription, they
consideration for
utilize
working
their
with
services,
non-relational data
whether
on
it's
Azure.
online
That's the topic
marketplace
name
or
given
maybe
on syllabus
some
of this
email
course on
service you are
Microsoft Learn
opting
page.
for, or you
And
are
the weightage of
using social
questions
media
comes from
platform.
15 to 20% from this
The
part.
way and the amount of
So
data
let's start.
used to be generated on daily basis.
Non-relational
For
database,
example,
any
there are
database that
200
is
billion
not based
tweets
on tables,
happen
rows
per
and
year.
columns, the
It's
way
just
data
about
is
one
stored is
single
supposed to
company,
better the
Twitter.
applications.
200 billions of tweets are
So in our
generated.
first video, we
And
learnt
if
about
we just
types of
include
data,
YouTube,
a
Google, and other such
structured,
companies,
semi-structured and
and
unstructured
also
data.
several
A
in
structured
online
data where
marketplaces,
we keep
just
the
think
data
about
in
the
row and
amount
column
of data
basis,
getting generated.
same
To
representation like
storing that
Microsoft
amount of
Excel,
data and
and
also
these are like
managing that
mostly
data,
organizational
because the
data
correct
where
data should be
we can
tagged to the
represent the
current
data we can
recipient. It
store in row
shouldn't
and
be
column based.
if I am logging into my Twitter and I
Semi-structured
am
data
seeing
where
someone
in
else
the data
Twitter
there is some structure
associated with
present,
my account.
but we
On any
cannot store
marketplace
them
I
in
ordered
row and
something, but
column
I
like
am seeing
JSON
some
file and
others
all. So
person
storing
information.
those kind of
So
data,
that's again a
we need
moral, social, and business
non-relational
ethics are
databases,
compromised.
and
So
the
managing
database
it
which
in correct
which
way
can store
and
semi-structured
storing
data
the
are
such
non-relational
big
database,
huge amount of data,
also known as a NoSQL. And
we need
NoSQL not mean
such format,
like
JSON
no
format
is not
or other
related to SQL.
semi-structured format,
It's not
and to
only
store
SQL.
them we
We can
need
query them,
non-relational
and but
databases,
this
and
is
these are
a
like being
part of
developed day
something
by day.
extra than SQL.
So imagine trying
So we
run
call it
query
as
on
a
table with 1
not only
trillion row.
SQL, in short,
So what
NoSQL.
if we store such huge data on table format, row and column format in a relational database, and if a user trying to find what I had ordered, what is the status in backend, some query is running over 1 trillion row, maybe it will take 10 minutes, 15 minutes to give the result. And imagine how much compute power is required to support such request. So it's not so good to go with such traditional relational database system. The way the requirement has changed, the way the usage has changed, the way the data is started getting created, it requires some more development, new methodologies, and new optimized services. So non-relational databases are optimized for such different uses. For how different uses, these kind of requirements. So first we will see what kind of data types comes under semi-structured data, which can be stored on non-relational database. So first, document data. Document data when are called like JSON format, JSON files, XML also. So here you see there is a key given. Inside that key, the document content is there. There is a customer ID 99 which ordered some product, quantity, cost, what was the order date, while some other person has ordered customer which is having customer ID 220, ordered some other product, quantity, cost, and order date is different. So you can see a different customer ID having different order items, as well as the count, the amount, and the column. So imagine if we are creating a relational database for them, someone is placing 100 order per day, someone is just placing one in a month, and for them if we are creating a denormalized huge table, so for second person we are just filling one column and have to keep all as blank, while because of the other customer which is having different column requirement, means their data required different column requirement, Instead, why not to store in JSON where different customers are their data can be stored in a way their columns different document can contain different amount of column. So that is why again and again I am saying non-relational are the requirement with this new uh, new changes over the internet. Here the benefit of having JSON file, you can have n number of column for different columns for different keys, different customers. We can have different information. Whatever information is available, we can append here. It is independent with the other one. And the Azure service which can store such information, Cosmos DB, the crown jewel of Azure. Next data type as part of semi-structure is a column family data. So let's say if we have uh, a data having 100 columns, out of those 100 we need to create a kind of family. Let's say 5 columns are coming from one kind of information, 5 columns are for other kind of information. So these families, this grouping, so if we store data with that groups, so identity I am making it as a family, and the first name, last name, suffix, title, all are representing something with someone's identity. Similarly, contact info, phone number, email. So these are like contact info, how I can contact that person. So customer ID here in this example you see 001 first name and last name is available, so I can store only this two information. For customer ID 002 he is also using a suffix junior, so I can store that information as well. While the third person do not have a suffix but have a title, so I can add that one instead of storing it in a tabular format and keeping most of the field as blank, which information is not available. Similarly, for this first customer, if I have only phone number, if I have both phone number and email, I am storing both, while for other I just have email, while for other I have just phone number. So here I have a privilege, I can store the available information of the family of the columns from that contact info family, which is containing let's say 3 columns. So whatever information I have, I am storing it. So data is stored by just storing their columns grouping, and such kind of data we can store on Azure Cosmos DB for Apache Cassandra. So if you are little confused with this name, so Apache Cassandra is a open source non-relational database storage service for a long time, and Azure is also providing service. You can store Apache Cassandra storage on Azure, and those are very simple steps. Even you can if you want to store your Apache Cassandra data on Azure, you just have to change the connection string and it's done. So in your subscription, the same whatever created for Apache Cassandra can be reutilized if you even if you are starting for very first time storing your fresh data on Azure. So next, column value data. So what is column value data? Key value data, sorry. So key value data where you create a key and that for value. So these kind of data is like very absolute, very rarely any organization go for storing and creating such data, but as part of concept. So maybe if you are a bookstore, so if you want to uh, create a database where you want to have all the information of your inventory, so maybe barcode is the key and the name of the book is the value, so you can store in such a way. And on Azure the available service is Azure Cosmos DB for table. So you can see Azure Cosmos DB how vulnerable it is. It is having so many facilities. Also, it supports many APIs. That is why I'm calling it as a crown jewel. And one more point before going to next type, I would say for relational database services, a lot of services are available for a long time. From 80s, we have SQL Server and other companies also like IBM, DB2, Oracle, and all. But the main requirement of the current time is this non-relational databases and their storage types. So next, graph data. So these are very common, these are very important and data type which is being used by uh, social media. So you must be imagining sometime, so I have added one person in my friend circle, and how I am started getting uh, suggestions which are common between me and the one to whom I have added. So they use a similar kind of graph. They, with your information, they create a graph data. So here you see there is a person called Robin. He knows Thomas. Both uses a laptop which runs on Microsoft operating Windows operating system. Now Thomas knows Ben. Both have a common interest of football. Ben uses a phone which runs on Android, while Robin also uses a phone which runs on Android, while they are located at different places. One is at Seattle, one is at London. But their common uses may give Ben a suggestion. You may know Robin because Robin knows Thomas, Ben knows Thomas, and also a part of this relation, they have a common relation. So, however, this example is related to mobile phone and Android operating system. But think about in the way. So maybe Robin is the from the college which Ben has attended, but at the college time they didn't know each other very much. But with the Thomas now using this social media, they can connect with each other. So this is the way they use this graph data is usually used to give you suggestions, build your own uh, network and all. So these are like the uh, basic concept of creating suggestions and all on the social media platforms. And to store such graph data, we have Cosmos DB Graph API on Azure. Next, time series data. So time series data is little related to IoT and AI ML, where you have some devices which are sending some reading, some value. So device 1 is sending value at like 90 at this time, while device 2 is sending another value 75 at this time. Again device 2 is sending some other at 1 minute later, it again sent some value 78. So continuously data is streaming and that required to be stored. So again this is non-relational database is required for this type of data. The data is called time series data and we can store in Azure time series insights. Object data stores. So object data stores are blob files. When I say blob, it's a large CSV file or TXT file. So you can say, see here, the files are placed in a path, a blob is created and a metadata is given. So metadata, what is metadata? It is some reference with something. So instead of calling like this is my laptop, I can say this is a machine where I create videos for YouTube on my channel. Also I use the same machine for sending email. So what I am giving a reference. This reference for what? That is for my laptop. So instead of calling it as a laptop, I am creating a metadata which is representing my machine. So for this file we create a metadata like this file was created on this day, maybe created on this day. So I am creating some metadata which is to represent this actual file. So storing in this way, we need to have Azure Blob Storage. that is a dedicated storage service given by Azure for such kind of requirement, storing blob files. External index data store. So in the previous example, object data stores, if I know my required data is stored in first file, so I can go and search this file, I can go to check the content of this file. But what if I don't know where my content is located? I do not know the file name, on what day it arrived. So what I can do, I can create external index. I can create external index name, and I can give a ID. So next time when I need to check where the name was Lewis and Clark National Historical Trail, through this ID I can navigate to the actual file. Similarly, if I know the county was San Diego and elevation was given as 1294 with two information where I can find this data. So the ID will be generated with that particular file or blob file which is containing this information. So here I am actually creating an external index, and that ID, through this ID I can navigate there. So this kind of external index, if we need to create, the Azure service given is Azure Search. So next, let's discuss about a non-relational data flow on Azure. So this is just an example how it can be done. So Azure has given several services there. As per our need, we just have to configure them. We have to take the subscription and we have to configure as per our requirement. So here we see there is some kind of device. This is representing some device which is creating the data. Maybe on a regular time basis it is creating some data. IoT hub, which is taking it on a stream, picking the data, sending it to Databricks. That is the Apache Spark based tool to process the data. We will talk about Databricks in very detail in our next video. Apache Databricks is sending to us Cosmos DB. From there, some kind of API is being used and going to any device. Let's say if I need to see that data over my any Android app through my mobile phone, or maybe on any web app. So from here, using some API, the same can be integrated. In parallel, some Azure function is picking the change. So since IoT hub is keep sending up the data, the way the same is being stored at Azure DB. From there, whatever change is being stored at DB, Cosmos DB, those are picked by Azure function and sent to Azure SQL Data Warehouse, that's now renamed as Azure Synapse Analytics. And on top of all, we can use a Power BI dashboard to do the further visualization. So in this example, I am trying to cover all requirements in one workflow. And this is not the all, like this is just a simple, very simplest example. As per the requirement, we can create different flow which can cater the actual requirement. So on Azure non-relational database, how it can be done. So now here you see there are some word written as hot, cold, again a cold. So what does it mean? That's we are going to discuss next. So these are the access tiers. What is access tier? Like how often you need to retrieve the data, or how often you need to access the data. You have to choose the access tier accordingly. So three kinds of access tiers: hot, cool, and archive. When you want to access your data very frequently, you have to choose for hot. If you have to access data infrequently but at least in 30 days, then you should go for cool. Now, if you are just storing the data as per your business ethics, and hardly you will be accessing it for 180 days, so you can go for archival. So why we cannot choose hot all the time, or why cannot we choose cool all the time? It depends on the pricing. So hot tier, if you are asking for, definitely that will have a higher price, but it all depends on requirement. So how often you are supposed to get the data? Maybe for reporting purpose the data will be kept, but you need to access once in a month for create some kind of report, or to send some other department or something. So if you are just accessing it in 30 days, so why to pay extra by taking a hot tier? Better you can go for cool. And if you are just storing the historical data, maybe you need it in a 6 month, even that's not sure. Then again, why to pay extra with cool tier? Better to give with archival tier. So in your exam, just a quick thing I would say, sometimes you will get some confusing question. So data is stored that you need to access once in 3 days. What access tier you should select? Hot, cool, archive. So here when it comes as a 3 day, people usually get confused whether it's a like a quick access thing or infrequent access. So these 30 days, 180 days and frequent, these are the keywords you should understand, you should remember. So 3 days when you see, again 3 days is not infrequent. Infrequent at least once in 30 days. So when you see 3 days is written, you should consider it as a frequent accessing. Once in a 3 day means after 3 days again data will be accessed. So this become a uh, frequent accessing. So you should go for hot option, not cool. And what if you get 45 days? 45 days is not archival. Archival, like once you are going with 180 days. So 30 days to 180 days, that time also you can consider for cool access tiering. So next, let's compare little bit between relational and non-relational. So for that, let's first see benefits of relational database. The benefits of non-relational database are normalization, reduces duplication, reduce mistakes, data relationship drive, data insight, integrity. Also, last topic I would say data enforce constant fixed schema. So, if you remember in our first video, we talked about ACID principle. So, if you are implementing ACID principle very well, the data would be very optimized, and there would not be any duplicate, there would not be any mistake, the data integrity would be excellently good. If you can create some function, so there won't be any case where you are if you are like giving rules very well, then if let's say bank account, if someone is A is transferring to B, then data integrity would be there, the amount from A would be reduced and B would be increased. Also, so many constants you can enforce, schema would be fixed. So these are the benefits of relational databases. Apart of this, many of the established products are decades old, bug free. Since I said few minutes back also, so most of the relational database services like IBM or Microsoft SQL Server, also Oracle, these are like they are in the market from 80s, and over the time they are receiving several complaints and bugs are reported, so they are keep fixing them over the time. This is very rigid stable systems, those are already went through many testing and many uh, challenges. So those are very stable, old, bug free. Power BI, you can also you can have Power BI services with relational databases, and have data visualization services very well. While when we talk about the benefits of NoSQL databases, these are optimized for a specific data types. So again, I'm pointing it out. We talked earlier. So we saw, I gave you multiple examples how the internet is being changed, how it is changed in last 1 decade and being changed day by day. The amount of data and the type of data and the business requirement associated with them, those are very near about impossible to store such data with traditional relational databases. So those are optimized for these specific data types. This can be designed for performance at internet scales. So when I say designed for performance internet scale, that means the way internet is expanding, the amount of data is being generated every day. Every new startup wants to go online, they want to have their own app or website or something. So the scale are getting increased day by day. So this can be like this, since this is a new development, these are designed to give higher performance with as the internet scale. Also, it's if you are not a big organization like Amazon, Twitter and all, it's impossible to have your own system, own development system to store such data. So mostly you will go with cloud services, any of the cloud services like Microsoft Azure. So you don't need to have massive hardware, which really reduce the expenses. So next, Azure non-relational options. We have 4 non-relational options available on Azure. Cosmos DB. Again, Cosmos DB is a crown jewel. It it is a very fast, very widely used nowadays. Also support many data models, graphs, document, table, column family. We can say it's a enterprise grade, very highly recommended, It's compatible with established APIs like Cassandra, MongoDB, Gremlin. So these are the names which is the existing open source non-relational data storage services like Apache, Cassandra, MongoDB, all are open source and currently being used by many organizations. This is compatible Azure Cosmos DB. You can select the data consistency as per your need. It's very easy to scale worldwide. So a 10 millisecond latency, very less latency. It is very fast. As again, I'm saying service level agreement for throughput, latency, availability, and consistency. Throughput means the uh, data loading speed. Latency means how much it takes time to retrieve the data. It's very highly available and consistent. So Cosmos DB is containing each and every feature that you will need. Next, table storage. It's your storage account 5 petabyte maximum limit. One important point, this is cheapest data storage option on Azure, and but you have to pay for your operations, but those price would be very less, like $0.00036 per 10,000 transactions. But one more important point, service level agreement is not good, 10 seconds for a query. So it depends at if your requirement is okay to have a query result in 10 seconds, then it's good. But in terms of normal, where the Cosmos DB you see 10 millisecond, where it is a 10 second, so the difference you can see, it's a huge. Now in this, more of the services are dealing in millisecond. They at least they say they are available within millisecond when you run a query. So SLA is not so good in terms of in comparison with others, but you can also consider this is the cheapest option and very high amount of storage is available. And this pricing, and also when I say cheapest, I'm not giving a fixed value because that depends on many other things, like how much how you are setting up your cloud service, you are going with multiple region or just multiple availability zones in single region. So it depends on multiple factor, and also region wise the price varies. But again, wherever it is, it will be the cheapest among other three. So next, blob storage, again 5 petabyte maximum limit. It is again a cheaper data storage option. Important point, it supports premium, hot, cool, and archive access tiers. And also it supports reserve capacity. So what is reserve capacity? Reserve capacity, when you reserve some storage a space in advance. Then what is the benefit of reserving in advance? It Azure gives you discount. You can avail up to 80% discount if you're reserving in advance. Like you can reserve from GB to 100 TB for like 3 years at that time. So just like it will cost you $0.014 per GB, up to 100 TB you can reserve. So reserving gives you a very good discount, and it support that facility. So if you know for a longer time you would be required a storage unit, you would be scaling over the time. If you are like in you are insured with that, it's better option to reserve capacity in advance to avail the discount. Also it support blob indexing. We saw earlier, we create external index to to blob files for the data contains. Also you have to pay extra for your operations, like $0.00036 for 10,000 transaction. But again, this amount is just for representation to show how cheaper it is. But again, don't go exact number, because that depends on the region and the services that you are availing, like locally redundant storage you are opting for, or you want to replication over multiple region or multiple availability zone. Service level agreement is not good here too, 2 seconds per MB. So again, you may see this is not a valid statement, because if you think as per your requirement or your understanding 2 seconds per MB is not a bad SLA, then it's good. It's not a defined thing, but it is a comparison. It's comparison and the requirement, the general trend that is expected nowadays. Based on that, it is written that SLA is not good. But if the customer's requirement is okay, they are waiting, they are not accessing the data frequently, or data is being used just to run the pipeline, and there this 2 seconds 10 seconds are not having much impact, then it's good. So last, file storage. Again, 5 petabyte maximum limit. And again, it's the cheaper data storage option. A standard and premier options available. Service level agreement, again poor, 2 seconds per MB, same as Blob Storage. So you might be thinking why I am giving this small details here. So these are required in your examination. These are important because you may get a question which one is the cheapest storage option, and the data type is not mentioned, simply it is written non-relational data among blob storage, file storage, and previous one table storage. So table storage is the cheapest one, so you have to select table storage. Maybe you can get another question, which of this storage supports cool access tier? File storage, blob storage, and the table storage, Cosmos DB. So you see cool storage is available on blob storage, so you should select blob storage. So you may get such questions in the examination, that is why I am pointing these points here. So that is all for this part. Thank you.